welcome back to another episode of this season. I'm thrilled to have a very special guest with us today. Our guest is Dr. Jivika Ranavira, who is here to bring us a lot of valuable wealth of knowledge in hardware engineering. Dr. Jivika Ranavira, welcome to the podcast.
Thank you, Ramudu. Uh, so I'm so happy to be part of this podcast episode, especially because it is on a topic that I'm very passionate about. As you can imagine, hardware engineering is the field that is responsible for designing and building the physical components that cover all the technical achievements or advancements that we are seeing in this world today. So, as we stand at the intersection of innovation and possibility, we are actually experiencing the key trends, groundbreaking technologies, and paradigm shifts that are reshaping the landscape of hardware engineering. So, starting from embedded systems that power our smart devices and vehicles, all the way to the complex circuitry of cutting edge processors, the hardware engineers are at the forefront of driving all these technological progress that we are currently seeing. So, as our world becomes more interconnected, more intelligent, and more reliant on hardware driven solutions, the role of hardware engineers is expanding beyond the traditional boundaries. So, as hardware engineers, we explore how emerging trends such as edge computing, quantum computing, AI, sustainability, and rapid prototyping are influencing the way we design, the way we build, and the way we innovate. So at the same time, we also look into the challenges and opportunities posed by the integration of diverse components, the need for greater energy efficiency, and the growing importance of cybersecurity in hardware systems. So with the recent mega trends, we also help make augmented reality, virtual reality, the Internet of Things, and metaverse reality. So, if you're curious about the technologies that will shape our lives, the challenges that will test our ingenuity, and the possibilities that lie ahead, then hardware engineering is definitely for you. So, that's just a brief introduction from my part, and we can go to the discussion now if you're okay with it.
Yeah, so it's clear that your insights will provide valuable perspectives and a lot of knowledge for our listeners. So, without further ado, let's jump right into our discussion on hardware engineering. So, madam,
Yeah.
the first question I have regarding hardware engineering is, what are the steps involved in getting started in a career in hardware engineering?
Yeah, sure. So, based on my own engineering journey, I can say that starting a career in hardware engineering can be very exciting and a truly enjoyable journey. So, here are some steps that I myself and others took to become hardware engineers. First, in terms of an education, you can begin by obtaining a bachelor's degree in electrical engineering, computer engineering, or a related field. This provides a strong foundation in technical knowledge that you need. And as far as technical skills, you need to develop proficiency in hardware design tools and programming languages like VHDL or Verilog. These skills are essential for designing and testing hardware components. Then you need to gain practical experience through projects, internships, or COP programs. These hands-on experience opportunities help you apply theoretical knowledge to real-world scenarios. You also want to choose a specialization within hardware engineering, such as digital design, analog design, FPGA design, memory design, or PCB design. This focus allows you to become an expert in a specific area. For an example, my master's and PhD focused on flash memory cells. So all of you can select an area that you are comfortable or passionate about and specialize on that. So while studying on these, you may want to build a portfolio showing your projects, your designs and accomplishments. This will be useful to show your skills to potential employers. It is also important to attend industry events and connect with professionals in the field. Networking helps you stay updated on industry trends and can lead to job opportunities. Becoming IEEE members as a student is very useful. You will get exposed to many opportunities through them. And also hardware engineers in or hardware engineering is something that evolves very quickly. So it is important to stay informed about the latest technologies, the latest tools and advancements through continuous learning. For example, you can learn about quantum computing, EVs, and chip development for AI applications to stay informed. Those are the current trends we have. The obvious next steps are looking for hardware engineering positions on job boards and company websites, then customize your application to match the requirements of each of these roles. And you also have to be ready to discuss your technical skills and experiences in interviews. And at the same time, do not forget to research the companies you are interviewing with, because with that, you will show that you are genuinely interested in working at that company. And one last thing is that once you are in the field, remember to continue learning to stay relevant in this dynamic industry. So just to finally remember that hardware engineering offers diverse opportunities across industries like electronics, automotive, aerospace, health, and many more. So you can also tailor your journey based on your interests and the availability and the available opportunities. Yeah, that's I think basically what I have to say about that question. Okay.
All right, madam. So that's some really insightful information for our people who want to do their career in hardware engineering.
Yeah.
So moving on, madam, could I know what are the soft skills that are most important for hardware engineers?
Yeah, this is something that I always stress or emphasize when I mentor students. Soft skills are crucial for hardware engineers to excel in their roles and collaborate effectively. And there are some of the and there are some very important one or most important soft skills that I have used in my own journey that I can share with all of you. The first one I would say is problem solving. Hardware engineers often face complex challenges. The ability to analyze issues, identify solutions, and adapt to changing circumstances is very important. I remember when I was a junior engineer, one of my mentors told me that companies hire engineers to find solutions to the problems they have, and not only to find problems and expect someone else to solve them. So finding solutions to existing problem is very important. You also need to pay attention to detail, paying close attention to like specifications, measurements, and layouts help ensure quality and functionality. Also, one of the skills I always stress as important is communication. Having clear communications with team members, clients, and stakeholders is very important. As hardware engineers, we need to convey technical concepts and progress updates effectively, either through reports, presentations, or frequent discussions with group members or team members. Then comes teamwork. Collaborating with colleagues from various disciplines is very common in engineering projects. So being a team player and respecting input from others definitely contribute to very successful outcomes. Also, you should be able to meet deadlines in this fast-paced engineering environment. So, learning to manage your time effectively can ensure that your project progress smoothly and in a timely manner. Another important soft skill is adaptability because hardware engineering actually involves evolving technology, and with that comes changing project requirements. So, if you adapt readily for these changes, you will succeed in and embrace new approaches and tools. Creativity is also very important. Innovative thinking helps engineers come up with novel solutions and designs. Creativity is particularly valuable when facing unconventional challenges. This may also end up with you getting a chance to apply for patents. So you can be an inventor if you're very creative. And when it comes to critical thinking, evaluating different design options, considering potential risks, and making informed decisions are all part of a hardware engineer's role. So when we advance in our engineering careers, we get also the opportunity to lead projects or mentor junior team members. So having strong leadership skills can enhance project success as well as your success as an engineer. And also important to have conflict resolution skills. When differences of opinion arise in any project, your ability to navigate conflicts basically constructively can help maintain a positive work environment. Uh, Finally, you need to be customer focused as well. Understanding customer needs and translating them into technical requirements is very important for creating hardware solutions that meet user expectations. So always remember, while technical skills are fundamental, it's the combination of technical expertise and those soft skills that truly set successful hardware engineering apart. So don't forget to develop these soft skills as well. Thank you.
Yeah, all right, man. So, as of now, I'm pretty sure most of our listeners might be thinking of this question. So, madam, what are some of the challenges that new hardware engineers face?
Yeah, actually, we do face a lot of challenges, especially when you're new engineers. So while entering the world of this hardware engineering, it brings really exciting opportunities. It can also bring some challenges. So some of the things that came to my mind uh, when you face like projects that are complex, and so hardware engineers are involved in intricate design and systems. So new engineers might struggle with the complexity of their initial projects because they are not sure about the ability to solve them. And also, lack of practical experience can be challenging. While education provides the foundation, practical experience is very important. New college graduates may find it challenging to apply theoretical knowledge to actual real world scenarios. So, doing a lot of projects and other internships really help with this. And also, due to rapid technological changes, hardware technology evolves very quickly. So, keeping up with the latest advancements and trends require continuous learning and adaptation. So, just getting your bachelor's degree is not enough. You need to keep on learning about new trends. And debugging and problem solving can be also challenging. You may find that identifying and resolving hardware issues can be time consuming and intricate. So, learning effective debugging techniques can help with this challenge. Also, another thing is interdisciplinary collaboration. Hardware projects often involve collaboration with software engineers, designers, and other professionals. So, effective communication across disciplines can be a real learning curve. So, then meeting tight deadlines while ensuring quality can be demanding, especially for new engineers who are still building their efficiency. Now, hardware failures can be costly as well. So, new engineers need to learn how to identify and mitigate potential risks in their design because you don't want your design to fail in the end. Uh, Also, you would like to learn new tools and familiarizing with specialized tools because that way you can acquire proficiency in these tools to make uh, and these things can take time, and also you need to practice a lot, so that can be challenging. uh, Also, explaining technical concepts to non-technical team members or clients can be challenging. Sometimes you may have to explain it to your vice president, who is not very technical but is a good manager. So you need to explain this in details. You should be able to explain to someone like that. So this requires strong communication skills. So, as I said earlier, developing strong communication skills is very important to your entire life, And also, uh, what else? I remember, okay, the new engineers also might struggle to find the right balance between theoretical knowledge gained in academia and practical skills needed in the industry. So, balancing theory and practice is also important. And there's something called imposter syndrome. I don't know if you have heard of this. Many new engineers experience this syndrome, doubting their abilities despite their qualifications. So, spend some time building confidence and learning from your mistakes so that you don't feel this imposter syndrome. Once you are done with your undergraduate degree, you may be wondering which hardware engineering path to take. So, for that, you may need to explore different specialties to find your ideal career direction as well. So, that's the challenging phase you will go through. So, with all this, I can say it's important to remember that these challenges are normal aspects of the learning process. We all have gone through, and all have made mistakes through these challenges. And overcoming them contribute to personal and professional growth as hardware engineers. So that's what I have to say about the challenges we face. Thank you.
Yeah, all right, miss. So, as we dive more into the hardware design knowledge, could I know what are the different phases of the hardware design process for embedded systems?
Yeah, that's a very important question because although you will be focusing in one phase only, it's better to know the entire scenario of the all the phases so that you get an understanding of it. So, especially the design process for embedded systems, involves several distinct phases. Every phase is crucial for creating functional and efficient devices. These phases typically include requirements gathering. That means first you need to understand the project's goals and specifications. Then you need to define what the embedded system needs to accomplish, including its performance, power consumption, and connectivity requirements. Then you need to plan the overall system structure, determine the major components that it needs, the interfaces, and how they will communicate. This phase sets the foundation for the design. Afterwards, you also need to choose the appropriate components such as microcontrollers, sensors, and communication modules. Then factoring these the factors included for this is performance, compatibility, power consumption, and cost. The cost is very important when you're designing something. Also, you need to do the schematic design by creating circuit diagrams that depict how components connect. Consider signal integrity, power distribution, and grounding to ensure proper functionality as well as proper reliability. Then we need to design the physical layout of the circuit, for example, a PCB or a printed circuit board. We had to place components optimally for signal integrity, minimize noise, and ensure efficient heat dissipation. Afterwards, you need to build a prototype of the PCB, test its functionality, verify that components work together, and identify any issues that need correction. Uh, then comes firmware development, writing the software that runs on the embedded system's microcontroller. This involves coding the necessary functionalities and implementing communication protocols. Afterwards, we have the integration and testing phase. We need to combine the hardware and firmware components, then conduct thorough testing to ensure the integrated system functions as expected and meets the requirements. Afterwards, we have to validate the embedded system against the initial requirements. This includes functional testing, performance testing, and ensuring compliance with safety standards. We've had to fine tune the design for better performance, power efficiency, and cost effectiveness. This phase may involve tweaking the hardware layout and the firmware code that we use. We have to go for certification and compliance phase, depending on the application. The system might need to meet specific industry standards or certifications. This phase ensures the system's safety and reliability. And if you're ready for production, then prepare the design for mass production by finalizing documentation for performing design for manufacturing, which we call BFM checks, and collaboration with manufacturers. In the manufacturing and deployment phase, the final design is manufactured and assembled into product. Quality control checks are performed during this, and the finished products are deployed to the market. Finally, it is very important to do maintenance and updates to the embedded systems because they often require ongoing support. You have to do regular updates, bug fixes, and improvements might be necessary to keep these systems current and reliable. So as you can see, each phase of the hardware design process is interconnected and plays a crucial role in creating successful embedded systems that meet user needs and industry standards. Although I mentioned about 14 phases, you don't have to be specializing in all of them. There are different groups that take care of each of these phases, but it is good to know about all of them so that you have a better understanding of the products being developed by your company. Thank you.
All right, that was so nice to hear. So, as we know now, as there's a lot of different stages during this hardware design process when we are making embedded systems. So, definitely there are some of the challenges that the hardware engineers face during the design process.
Yeah, definitely a lot of them. So the hardware design process is really dynamic and rewarding, but it also comes with its fair share of challenges and obstacles. The first one is complexity and integration, because modern systems involve intricate components that must work seamlessly together. Integrating diverse hardware components can be a complex task. Also, we meeting project deadlines while ensuring quality can be challenging. The pressure to deliver on time can impact decision making and potentially leading into error. When it comes to cost constraints, designing with budget constraints is essential. Balancing performance and features with cost effectiveness can be difficult, especially for very ambitious projects. Hardware engineers often face limitations in terms of processing power, memory, as well as the space that they have to design. These constraints can impact the design's capabilities. Then we also have to ensure proper signal integrity and minimize noise or electromagnetic interference, which we call EMI, because noise can affect performance and reliability. Managing heat generated by components is a critical concern as well. Inadequate heat dissipation can lead to thermal issues and affect the longevity of the hardware that we are designing. Also, ensuring that hardware components from different manufacturers work together smoothly can be a challenge. So, pay close attention to any compatibility issues that might arise unexpectedly. Rigorous testing is necessary to verify the functionality and reliability of the design. Developing comprehensive test plans and identifying potential flaws can be very time consuming as well. And meeting industry standards and regulations is essential, particularly in safety critical applications. So ensuring compliance can require additional design considerations that some of you may find challenging. And staying current with rapidly evolving emerging technologies is a challenge. So incorporating new advancements while maintaining stability can be a balancing act. Then there are also chances that you may encounter unforeseen design changes because design requirements might change midway through the project due to market shifts or user feedback. So adapting to these changes can sometimes be disruptive and very demoralizing as well because you may think that you have worked so long, why can't we continue with the same way? But no, you have to stop everything and go back to start from the beginning and do something else because that's what your boss or the company would decide as a new direction. So you should be able to uh, change your focus based on that. Also, it's important to do debugging and troubleshooting to identify and resolve hardware issues. And this can be time consuming and require in-depth technical expertise. You will also have to anticipate and mitigate any risks, such as component shortages or unexpected failures, because they are going to be part of hardware engineers' role as well. So, as a hardware engineer, you can leverage your expertise, problem-solving skills, and dedication to create innovative and reliable solutions that drive technological progress. Once again, you are not expected to solve all these problems that come up, but it is always good to know of them and step in to help as needed. Thank you.
All right. So those are some fascinating points that you made because now people would have the and very idea about how to face these challenges. So as we are going on through this podcast, I'm pretty sure people might be having this question in their mind. So, madam, what are some of the latest trends in embedded system hardware design?
Oh yes, embedded system hardware design is definitely, I mean, constantly evolving, driven by technological advancements and industry demands. So some of the latest trends include edge computing. So with the rise of IoT, Internet of Things, edge computing has gained prominence because embedded systems are becoming more powerful to process data locally, reducing latency and dependency on cloud services. Embedded systems are also incorporating AI and machine learning capabilities. So hardware accelerators such as GPUs and specialized AI chips are being integrated to perform real-time inference tasks. Um, Energy efficiency remains a top priority. Hardware engineers are focusing on developing energy-efficient, low-power designs to prolong battery life in devices and reduce environmental impact. Also, embedded systems are becoming more capable of handling demanding applications. So, this trend is driven by the need for faster data processing with high performance computing in fields like autonomous vehicles and robotics. FPGAs or field programmable gate arrays offer flexibility in hardware design. Engineers are using FPGAs for tasks requiring parallel processing, acceleration, and adaptability. Also, ensuring the security and of embedded system is critical, especially with the proliferation of connected devices. So, hardware engineers are implementing robust encryption, authentication, and secure boot mechanisms to ensure that their products are secure and trustworthy. Also, as wireless technologies evolve, embedded systems are incorporating advanced connectivity options like 5G, Wi-Fi 6, and Bluetooth Low Energy for faster and more reliable communication. Also, heterogeneous integration, which is combining different types of components such as CPUs, GPUs, and memory on a single chip to enhance performance and efficiency is also a trend. Um, there is also the trend for rapid prototyping and agile development, where engineers are leveraging tools and methodologies to accelerate the development cycle and quick iteration on design. Also, embedded systems are being designed with customization in mind. This enables tailoring products to specific user needs, resulting in more personalized experiences. I can also think about environmentally friendly design practices for sustainability and green design, and they are really gaining traction right now. So engineers are considering factors like recyclability and low energy operation during hardware design. Also, real-time operation systems, or what we call as RTOs, are increasingly used in embedded systems to manage tasks and scheduling, ensuring precise and predictable responses in time-sensitive applications. Another thing that is important is cybersecurity to make sure that cybersecurity measures that is also trending because with growing concerns about cybersecurity, hardware engineers are implementing hardware-based security mechanisms to protect systems from any kind of cyber attack. Also, hardware designs for AR and VR applications are becoming more sophisticated. demanding powerful processors, sensors, and specialized hardware. So these very interesting trends are shaping the future of embedded system hardware design, enabling engineers to create innovative, efficient, and secure devices for a wide range of industries. So knowing all these trends, you can decide based on your passion to specialize in one or some of these areas.
Right. So, as we are reaching the end of this session, I have a final question to ask. So, how are these trends changing the way hardware engineers design embedded systems?
Yeah, very. I like that question. Yeah. So, yeah, these emerging trends in embedded system hardware designs are significantly impacting the way the hardware engineers approach our work. The first one that I can say is design flexibility and versatility. Integration of AI, machine learning, and reconfigurable hardware like FPGA enables engineers to design systems that can adapt to changing requirements and perform complex tasks. The emphasis on energy efficiency is also leading to innovative power management techniques, enabling longer battery life and reducing the environmental footprint of embedded systems. Trends like edge computing and IoT demand collaboration between hardware and software engineers, ensuring seamless integration and optimal performance of systems. The increasing concern over cybersecurity is actually driving hardware engineers to implement hardware-based security features right from the design phase, ensuring robust protection against any kind of threat. With the demand for personalized experiences, also hardware engineers are designing systems that allow customization, tailoring products to individual user preferences. Then rapid prototyping tools and agile methodologies are accelerating the design cycle, enabling engineers to iterate quickly and respond to evolving project needs. In applications requiring real-time responses, such as autonomous vehicles or industry automation, engineers are focusing on designing systems that deliver precise and predictable outcomes or conclusions. So, with the wireless connectivity challenges, with the adoption of advanced wireless technologies, we can design for seamless connectivity. Consider factors like interference, range, and latency when we are designing them. Also, integration of cutting-edge components require incorporating components like GPUs, AI accelerators, and advanced sensors that present opportunities and challenges in terms of system optimization and thermal management. Because of the sustainability requirements, environmental concerns are driving hardware engineers to design systems with lower power consumption and materials that are more eco-friendly and recyclable. That's something also you can think about it, and if you're passionate about the environment, that's a place to like specialize if you would like to. And digital twin development. Hardware engineers are contributing to the creation of digital twins, virtual replicas of physical systems to simulate and optimize real-world operations before implementation. This actually helps with the environment aspect as well. The first industry influence that we see. So with that, the trends, with the number trends that we are seeing, they are blurring the lines between industries. For instance, advancement in embedded systems designed for augmented reality and virtual reality are now influencing healthcare, gaming, and education as well. So overall, these trends are pushing hardware engineers to become more adaptable, interdisciplinary, and forward think, I would say. So by embracing these changes, engineers are shaping the future of technology, creating smarter, more efficient, and secure embedded systems. Yeah, so that's thank you. That's all that I have to say about that question.
Yeah, so I think all our listeners here would have had a very informative session about hardware designing and how hardware engineering has helped in embedded systems.
Yeah.
So,
Mm-hmm. Thank you.
finally, madam, could I know what do you think of this podcast?
Oh, I think it's. I also went. I really love the way you do it and the way you accommodate my time schedule. You know, it's late in the night for you guys, and so I'm happy with that. And also, I think when I checked all the other podcasts you have had, like it's I just see it's good. Interesting to see how we have selected very important uh, like topic for podcast that is useful for all the students and even the people who are working. You know, I mean, I think it's not just for the students in Sri Lanka. I think anyone, since it's publicly available, anyone should be able to learn from these podcasts and apply what their learnings into their given careers. You know, so I was very impressed when I saw all the things you guys have done.
Alright, so that wraps up another insightful episode of our podcast series. I'd
Mm-hmm.
like to extend a heartfelt thank you to our guest, Dr. Jeevika Ranavira, for sharing her expertise and experience with us. I hope all our listeners found today's discussion very valuable and got more knowledge regarding this hardware engineering field.